All right, how the impulse momentum theorem can be applied. Following examples will show using the impulse momentum theorem to solve problems. Note that these problems can also be solved by using stuff we've already learned in the past. You can use the net force, stuff that makes it go minus stuff holds it back, equals mass times acceleration, and you can use velocity as a function of time. We're going to look at a parachute, a ball thrown, and something else. 5 kilogram skydiver moving downward at 60 meters per second needs to slow down to 10 meters per second during the course of 2 seconds. What net upward force must the parachuter provide? At this point in the class, you're probably having the instinct. We're talking about force, so start with the free body diagram and then go to Newton's second law equation, stuff that makes it go minus stuff that holds it back, equals mass times acceleration, and you can solve for acceleration, but there's a time involved here. There's a time constraint here, so we're going to need to find the acceleration first using kinematic equations. Use the velocity as a function of time, get your acceleration, take that acceleration, plug it into F equals ma, and we get F because we have m. That'll work. I don't care if that's what you want to do it. If you can do it quickly because you have those equations memorized and the concepts down pat, then do that. If you don't and you want a potentially shorter way to do it, then let's talk about the impulse momentum theorem. The impulse momentum theorem allows us to relate force to time. For this, we're going to call up positive. So our final momentum equals impulse plus the initial momentum. There it is in the equation form. Plugging in our numbers, if up is positive, down is negative, we get this, and then finally F equals 1,250 newtons. If we solve this using motion and forces, we're going to have to use V equals AT times V naught to solve for acceleration. Acceleration equals 25 meters per second. Use F net equals ma to find force, and we're going to get 1,250. Whatever, I don't care. You do whatever it is you want to do, as long as you get the right answer and you know what's happening.